5. There is all those fancy formulas from our notes, but I think we can do it without this for the most part. It says the equation that identifies the decibel level for any sound is L equals 10 times log base 10 and then I over I naught. There's a lot of letters there. So I think it's smart to write out what each letter means. L is loudness. So I would write that. L is how loud something is. Loudness. Is that a real word? Loudness. I is the intensity of sound. I, intensity of sound. Intensity. And I naught is the intensity of sound at the threshold of hearing. I naught. Oh, you did purple again. Sorry. I naught equals intensity threshold. That's what I'm going to say. I don't know what that means. I assume I naught is like the quietest you could be before you could hear it. Threshold of hearing, that's kind of what that sounds like. That seems legit. Let's say it's that. Given that a normal conversation is 1 million times as intense as I naught, then loudness is. You're looking for loudness. Loudness is. If you know what you're looking for, they have to provide the other things or provide multiple equations, right? In this case, we only have one equation and there's one thing we're looking for. That means I must have values that I can sub in for I and I naught. I don't really have values I can sub in for I and I naught. What they told me was that a given conversation is 1 million times as intense as I naught. What that means is if you took I and divided it by I naught, that would equal 1 million. Yeah, so that means I divided by I naught is going to be 1 million for whatever those values actually are. If you want to make it 1,000,001, you could do that too. But the whole idea is that this fraction here is 1 million. So my question becomes L equals 10 log base 10 of 1 million. Whatever I naught is, I is going to be 1 million times bigger than it. Kind of like the question we did earlier today. That was earlier today with the 2A and the A. Right? Like no matter what the values of this vehicle or whatever it was, investment was, when I divided it, it was always going to be double. Same thing's happening here. When I divide those values, it's always going to be 1 million, no matter what you chose for those values. If you put that into your calculator, log base 10 of 1 million is 1, 2, 3, 4, 5, 6. And then times that by 10, it's 60.
Also kind of like logic that like 16 decibels is way too low.
Yeah, if you knew anything about decibels, yeah, that would actually work out in your favor.
That what?
Like if you know like decibel ratings, like if you know the scale, like 16 decibels is like super quiet, like super quiet. Yeah. Yeah.
80 decibels is a baby crying.
80 decibels is a baby crying, which is pretty loud. So a normal conversation would be a little bit quieter than a baby crying. That makes sense.
Conversations in here like.
So just go memorize a decibel chart of random sounds, and then you'll get the right answer.
Just know how loud a baby cries, and you're good. 1 more second.
That works.
Yeah.
I'll memorize that. Earthquake intensity. So same idea. We've got like this idea of intensities, right? Earthquake intensity is given by I equals I naught times 10 to the power of m, where I naught is reference intensity. M is magnitude. An earthquake measuring 6.4, it really should say magnitude 6.4. Or it should at least tell you. I feel like it should reuse that word so that you know 6.4 is a magnitude. Was that obvious that 6.4 is a magnitude to you?
Yeah.
No? Yeah, some. Yeah. It should have said like a 6.4 on the Richter scale or magnitude 6.4. It should have said something to make it a little bit more clear. An earthquake measuring 6.4 is 220 times more intense than an second earthquake. Determined to the nearest tenth the Richter scale measure of the second earthquake. Okay, we are going to use the formula, but we're going to use my formula. So my formula is that the intensity will equal 10 to the power of the larger number divided by 10 to the power of the smaller number.
That's the same one she had here. It was just
Same one?
stronger over weaker.
Stronger over weaker, larger over smaller. Yeah, that works.
You guys are on the same.
We're on the same wave page. That's good. Wavelength. It's the page, something. We're on the same magnitude. Filling those values in. So intensity is 120 times or 220 times more intense. So I've got 220 equals. The larger number will be on top. 6.4 is 220 times more intense, so that'll be the larger number. 6.4 is on the top. Divided by 10 to the power of x on the bottom. I know it's 6.4 on the top because 6.4 was more intense. If it had been less intense, the 6.4 would have gone on the bottom because then it means it's the smaller earthquake. It's less intense. Cool, solving that thing. You're trying to solve for x, which is in the exponent. First thing I'm wanting to do is get this off the bottom by multiplying by 10 to the power of x to the other side. And in the same move, because I'm running out of room, I'm going to divide by 220. A little bit of cross multiplication, right? So I now have 10 to the power of x equals 10 to the power of 6.4 divided by 220. That's about the ugliest algebra I've ever done. I'm just cross multiplying and I'm dividing that 220 to the other side. To solve for an exponent, you change it into a log. This becomes log base 10 of 10 to the power of 6.4 divided by 220 equals x. You can put that in your calculator. I have made an absolute mess of using my space here. I apologize, but not really.
It's the end of the year.
It's June. X is 4 point, nearest 10th, 4.1. It makes sense that that's a smaller magnitude because it was the 6.4 was more intense. Had my answer been like 8.9, I'd be like, something's fishy because that's more intense, which it shouldn't be. The second earthquake was less intense.
So you should memorize this one.
Yeah. Honestly, I think this one will cover you for most part. I know that the pH scales get a little bit messy just because of the idea that acidity is a lower number.
Next question.
Is a pH one? That's good. But I always depend on this. Just 10 to the larger divided by 10 to the smaller gives you my intensity. So, number 7, distilled white vinegar has a pH of 2.2. If a particular food is approximately 2,512 times less acidic, which of the foods below could it be? We get blackberries, blueberries, white bread, cooked broccoli. Not acidic at all. Using that formula of intensity equals those numbers divided by each other, I have 2,512 equals 10 to the power of the larger number because it's less acidic. Oh, I see. Larger over bigger still works here. I don't think so. like because it's 2,512 times less acidic, like that number has to equal something. This has to be the bigger exponent. It's the only way it's going to equal 2,512. The weird thing is that when you're less acidic, it's going up the scale. Yeah, it should give you the same answer. The one that we did in our notes before, it was like this. Sorry, I'm going to write out what's in those notes. Its intensity equals, right?
Yeah.
Equals 10 to the power of negative more. More acidic.
Yeah.
Divided by 10 to the power of negative less acidic. What I'm doing is I'm saying that those negatives move the thing. So instead of doing it with negative exponents, I would do 10 to the power of less acidic, but the bigger number, divided by 10 to the power of more acidic, but that's the smaller number. And it's going back to this idea. Larger number is going to be on the top, smaller number is going to be on the bottom. It's just that negative moving it. That's the only difference. To solve this, I have to multiply the 10.2 to the other side. That gives me 398,125.1699, or you could leave it as an exact value. Solving for an exponent, you turn that into a log. That means you do log base 10 of that big number, 398,125.1699. That will tell you x. 5.6. Our friend the white bread. It's not. So the higher the number, the less acidic you are. So you're 2,512 times less acidic, even though it's the bigger number. Again, that's why I just always do bigger number, larger number on the top, smaller number on the bottom.
But it could work better to your advantage in case, like a certain way, because then you'll have to do like less dividing and stuff.
The only way they could make it really messy is if they said, if something was more acidic. Oh, but they're not going to do, yeah. This is not how you describe things. Weird. Anyways, if there's ever a question that says white bread is the answer, you should pick it anyway. Because that just seems funny.
White bread.
White bread.
What's they got against?
White bread, yeah. Okay, let's do, we'll do some transformation stuff. Yeah, I eat brown bread too. No, we'll skip through. Again, this is like ideas of things you should know how to do. So you read it, it's like, yeah, okay, I know what they're talking about. I just think it's better to do questions, personally. Question numero uno. The graph of f of x equals x squared minus 2 undergoes the transformation f of x plus 1. If a student wishes to graph the transform function in the calculator, the equation that gives the correct graph is. This is actually a good one to start us off because we screwed this up mightily for quite a while. And it was like how to apply these transformations into a function. So if in function notation, like this means like change x to become x plus 1. So like if I wanted to graph this new function, f of x plus 1 is as if you literally changed x to become x plus 1. And then squared minus 2. Like that's what the transformation actually looks like.
Pretty smart.
Most of the time.
Makes sense.
I feel like you never showed us this.
Yeah, you did. I remember.
I've been showing you it since grade 10.
Yeah, you definitely showed us this.
So then the answer is just C.
Oh, that's not so bad.
That's not so
We've been
bad.
done for so long.
Yeah. Ask it. Do I need to mute it before you ask it? Do you want me to mute it before you ask it? You like seem nervous. It's because I botched it. But that's coming. Sorry. This one. If the graph of f(x) equals x squared is transformed to the graph y plus 2 equals fx plus 1, then a true statement regarding the two graphs is the domain stays the same, but the range is not the same. The range is the same, domain not the same, whatever. Let's talk about what these transformations are, and then maybe do a little sketch so we can see what actually happens here. I don't like the way this is set up. If you went to any of those like Rock the Diploma things, they might like the way that you've set it up. I don't. I personally like to get y by itself. I don't know why, that's just me. So I would move that 2 over. And then that just makes me happier. And then I'm going to identify these transformations. So what is this plus 1 doing? 1 unit left. Perfect. And what is this minus 2 doing? Perfect. So we took this graph, which is x squared. We moved it 1 to the left and 2 down. If you were to just do a quick sketch of what that looks like, a basic mother function of x squared looks like this. The vertex is at the origin. It goes off to the left forever, off to the right forever. We took that graph, we moved it 1 to the left and 2 down. It now looks something like this. Obviously not very to scale, but the idea is that you see it went left and down. And just doing that rough like sketch of, well, what does this now look like, I should be able to tell if my domain and my range changed or not. Does my domain change? No, it's still XER. It goes forever left, forever right, no matter what. Does my range change? Yeah, most definitely. It goes lower now, right? So I'm looking for domain stayed the same, range changed. The domain, but not the range, is the same. What a terrible sentence. The domain, but not the range, is the same is right. The domain is the same, but not the range. Yeah, what a terrible sentence.
Did you make this?
No, I'm going to blame that on the English teachers. Surely that makes sense to them, and they did that.
The domain?
The domain, imagine this part like this. The domain is the same, but not the range. What a terrible way to put that. What a terrible way to write that.
There should be a comma after. Oh no, never mind. They should just rearrange the sentence.
Yes.
Get rid of.
I would put the domain is the same, the range has
I
changed.
think that's like you learned that in like grade 8 though. It's called like con about like how you can rearrange sentences so it means the same thing and it's still totally proper. But
Yeah, like when it's like embedded with commas, right? You could remove that part of the sentence and it still makes the right sentence. And you could move it, it would still make it the right sentence.
wait, so for this question, if there was no 2 and the x squared.
Had there been no
X
minus,
squared.
had there been no minus 2, the graph would have never gone down, right? So the graph would be at the same level, and so it would be the same domain and the same range.
So the x squared and the plus 1 doesn't change anything.
Right.
Why?
Wait. The plus 1 doesn't change the domain or range.
Because it just moves it 1 over.
Yes, and the graph already went forever left, forever right. Yeah. And the x squared has nothing to do with my transformation. The x squared is like my mother function. So this is how I started. That's
And it's saying if you apply.
and then I'm not saying I've gone left. Yeah.
Gotcha.
Number
Range always confused.
3. Just blame your grade 10 teacher. Wasn't me, right?
I was the oh wait, no, that was my grade 9.
Yeah, you were.
I did grade 10 online.
Yeah, grade 10 was all online for you guys. You guys just blame everything on grade 10. You get something wrong, grade 10's fault.
Oh yeah, grade 10.
Grammar 10, not you.
I didn't teach any of you guys till grade 11. I taught 0 of you guys.
Yeah.
Should you gotta tell me to mute first?
Pause the video.
I'll take credit for all the good things that happen and all the bad things, not me. Yeah, I like that. Which is and the start of COVID year too, which was like even nobody knew what they were doing. Yeah.
You just didn't show up for anything.
Yeah.
It was like one Google Meet a week.
Yeah, it
Nobody
was
knew what they were doing.
it was a mess.
Everybody cheated all the time.
Everyone cheated at every
We used
moment.
to Google call each other during quizzes.
I actually don't think I cheated.
Is it?
Oh,
Is
wait,
it
I
muted or
used
is it
to-
on?
Yeah.
I don't.
Yeah, watch how fast I can. Watch how fast I can math. Kool-Aid jammers. That is good. That's a good treat.
And cupcakes.
I love it.
For after we're done our games.
Today's last day. Okay, number 3. The point 2 comma negative 4 is on the graph y equals fx. The point must be on the graph of y equals blah, blah, blah is. Okay, what are the transformations that have happened here? Vertical stretch by 2.
Horizontal reflection.
Horizontal
The y-axis.
reflection. And
There, yeah.
6 up. If you were to write this in like mapping notation, 6 up, you would be doing negative your x value. You would double your y value, go up 6.
Wait, that's mapping notation?
That's what all messed up on that.
Yeah, that quiz, you guys bombed the mapping notation.
I didn't know what that was meaning.
The nice part about the mapping notation is if you can do this, then you just apply the transformations to your point. Right? So then it would be negative 2, comma 2 times negative 4 plus 6. And that'll tell you where your new point is. So it's at negative 2, comma negative 2. See. Remember that like horizontal things apply to the x value, vertical things apply to the y value.
Because it's a V and it looks like a Y.
Yes.
Yeah, sure. Or because vertical means up and down and y values are up and down.
Meanwhile, you're just like, yeah, okay, Emily.
Yeah. Really, v's and y's are pretty much the same thing. Yeah.
Are. Have you seen little kids draw Y's and draw B and then they draw? Yeah. That's not
True, they do.
It's okay. Mr. Breitenbach told me it counts for it.
He
Give
did
you
in
the
fact.
cat.
He did in fact.
Number 4. Then we'll be done. The equation that would cause the graph y equals g of x to vertically stretch about the x-axis by a factor of 1/4 and then reflect in the y-axis is. Okay, so if you vertically stretched about the x-axis by a factor, vertically stretch about the x-axis by a factor of 1/4, that would be your a value. And then reflect over the y-axis. Reflect in the y-axis. That's your b value. Remember, if you're flipping over the y-axis, right, it's your x values changing. So my new function would be 1/4 g of negative x. You're reflecting over the y-axis, so it's your x values changing.
Oh,
So it's a
over
right?
Y.
You're reflecting
Well, when it says
in
the y-axis.
the y-axis. Yeah, it means like over it.
Oh, that's so confusing.
I know. English is hard for most math teachers.
Wait, so like, could that be like the level for diploma questions? That seems a little easy.
Yeah, you could get something like that. And that wouldn't be that bad.
How many questions is it again? It's like 40?
24 multiple choice, 8 numeric response, and then 3 written problems, which is about, give or take, 8 marks. So you're looking at about 40 marks.
I feel like what are the